Welcome back, everybody. Moving on to the next question, we have to describe the transformations that must be applied to create the function y equals negative in brackets 3x minus 12 to the power 3 minus 2. So notice that the parent function of this is y equals x cubed. And we are transforming this to get to that. So if you remember, the general transformation format is what? AF of k bracket x minus d plus c. So if we specifically apply that to this function, in general, the way that x cubed is going to look is it's going to be a bracket k x minus d to the power of 3 plus c. Alright, so notice how this is almost in this format except for this 3 here. Notice how it's attached to the x, and here the x is by itself. So what we have to do is we have to manipulate this function that we are given a bit. So y equals negative. Let's take out the 3, but keep it in that big bracket, and we'd be left with x minus 4 here. And this would be to the power of 3 minus 2. And now notice how we can match everything up. So the a value is what? It's negative 1. The k value is 3. The d value is 4. And then the c value is negative 2. So what are the transformations here? An a value of negative 1 means that there is a reflection in the x-axis. There's no vertical or vertical stretch or compression going on, right? Because of this 1, it just stays as is, but because it's negative, there's a reflection in the x-axis. This k value of 3 means that there is a horizontal compression by a factor of 1 over 3. This d value of 4 means that it is translated 4 units right. And then this c value of negative 2 means that it is translated 2 units down. Alright, so those are the transformations that happen. Now, if you remember with x cubed, you technically don't have to have a k value, because if I further manipulate this up here, so we can have this like negative 1, and then we can distribute this exponent 3 to this term and this term. So we'd have like 3 to the power of 3, and then x minus 4 to the power of 3, and then this minus 2 would still be outside. Well, notice 3 to the power of 3 is 27 times negative 1, so that would give us negative 27 in front, and we'd have this x minus 4 to the power of 3 minus 2. And now notice how there's no k value, or rather the k value is just 1, but now we have this a value. Here, in this function, the a value would be negative 27, meaning that there would be a reflection in the x-axis still, plus there would be a vertical stretch by factor 27. And then the k value would be 1, so there'd be no horizontal compression or stretch. D value would still be 4, c value would still be negative 2. So instead of a horizontal compression by 1 over 3, if you're dealing with the function x cubed, remember this is only for this parent function, no other function. A horizontal compression of 1 over 3 for x cubed is the same as a vertical stretch by 27. So instead of writing that, you could have also wrote that. But most teachers just expect you to write this horizontal compression by 1 over 3. But as I've mentioned, you can have, when you're dealing with x cubed, x to the power 4, you technically never have to have a k value because you could always factor that out, bring it in front, and it could just be your a value.